there, we've got simplifying rational expressions. So, whenever we look at something, so today we're just simplifying. We are not solving equations. We will not get answers like x equals 2. We are just taking the expression that it has given us, and we're making it more simple by canceling out anything that we can possibly cancel, reducing anything that we can reduce. So, whenever we have a problem like example 1, the first thing that I want you to do for these problems is you need to tell me what the excluded values would be for this expression. So, whenever we talked about domain of functions, what was one of the things that gave us trouble? Logs? What else? Fractions, particularly. What about the fractions? Their denominators cannot equal 0. What was the third, just so we remember it? Square roots, right? We can't have negatives in a square root. Now, logs and square roots are not going to show up here. Denominators of fractions is what we're concerned with, all right? So the first thing that I want you to do for these problems is look at the denominator. And so my denominator is 5x, and that cannot equal 0. And so if I solve that, I divide both sides by 5. X cannot equal 0. So whatever we get as our simplified expression, we need to add to it the x cannot equal 0. Because what's going to happen on a lot of these is that denominator might cancel out completely, and it might look like 0 is okay, but it's really not. Okay. So this is our excluded value. We cannot plug in 0 to this. So once we've considered our excluded value, we are going to look at what we have. We want to reduce any coefficients that we can reduce, cancel any x's that we can cancel. So if I've got 45 on top, 5 on bottom, will those reduce? They will. I can divide both of them by 5. That will give me a 9 on top, a 1 on bottom. You don't have to write the 1 if you don't want to, but I'm going to for right now. Then I have 3 x's on top and only 1 on bottom. I'm going to write this out the long way just to make sure everybody's with me here. So if I got 3 x's on top and only 1 on bottom, if I have an x on top, it can cancel with one of the x's on bottom, right? Just leaving me 2 x's on the top. So this is going to be 9x squared. I could put it over 1 if I want to, but that makes me look like I don't know what I'm doing, right? Because something divided by 1 just equals whatever that something is. So 9x squared, but x cannot equal 0. So we just add in that excluded value there at the end. So, I mean, you can write this out every time where you write all your x's out on top and bottom and mark them out one by one. But you should see that basically what's happening here is you're just subtracting those exponents. This had an exponent of 1, even though it wasn't written. 3 minus 1 gave us 2. Okay, any questions on number 1? All right, take a second to write down number 2 if you haven't already. Okay. For the second one, we need to do excluded value. And so denominator 56x to the 7th cannot equal 0. So you divide by 56. X to the 7th cannot equal 0. We would take the 7th root of that. But what is the 7th root of 0? still 0, right? You don't necessarily have to show work for this. It is not. On number 3, it'll be different. So we'll see what's going to happen there. But if you just have a term where it just has an x with it, you don't have any plus or minus signs, it's going to be 0 there. For this, I need to see if anything will reduce. 28 and 56, is there anything I can divide both of those by? What? 28? Okay. So we can divide by 28. So that gives us a 1 on top and 2 on bottom. Then I've got 3 x's on the top, 7 on the bottom. If I subtract those, 7 minus 3 gives me 4. Where should I put those x's, top or bottom? Bottom, because there's more x's on the bottom, so that's where it's going to stay. The 1 here is very necessary, right? We don't have to write the 1's in the denominator of a fraction, but we definitely need them if the only thing we have left is the 1 in the top of the fraction. So we'd have 1 over 2x to the 4th, but we would say over here that x cannot equal 0 for our excluded value. I don't want you to leave them as negative exponents. So if you do it the way I just did it, I just did biggest minus smallest, and I got 4, and I put it wherever there were more x's. Another way you can do this is you could do it this way. You'd have your 1 and your 2. You could do 3 minus 7, top minus bottom. You'd get x to the negative 4, but it would be in the top there. And then for negative exponents, have we done any negative exponents in here? What do you have to do with negative exponents? You got to move them back down to the bottom, which would give you the 1 over 2x to the 4th. So I do not want you to leave anything with negative exponents here. If you just do the way I did the first time, you won't really run into negatives that way. Okay. Now, for example 3, let me show you. Make sure this is locked in place here so that I can erase. Don't do what I'm about to do. It's locked in place. Okay. Don't do what I'm about to do. But let me show you what children do. Okay. This is what they do. They're like, oh, x here, x here. Answer is 2 over x squared plus 5 plus 6. 2 over x squared plus 11. That is wrong. Here's something else they might try. They might cancel this x with maybe one of these x's right here. Now they're going to get 2 over x plus 5x plus 6, which will be 2 over 6x plus 6, which actually would reduce to 1 over 3x plus 3, although if they canceled that way, they probably didn't reduce it either. Can I do that? I cannot. Okay? Now, no matter how many times I say it, there's going to be a number of you that still do it. Let's make ourselves a note over here. You can not cancel terms that are separated by plus or minus signs. Okay, let's think about why. If I give you something like this, 1 plus 2 over 2 plus 3. Right? That, you guys should know, is 3/5. But if we apply the bad canceling that I was just doing over here that I showed you a second ago, if I did that same problem that way, that would mean I would cancel this 2 with this 2. and I would get 1/3. Is that right? No. It's terribly, terribly, terribly wrong. So, if you have terms that are separated by plus or minus signs, you cannot cancel. However, students do it daily. Sometimes I say that every time you cancel this way, it kills a tiny math fairy somewhere. So there's been a lot of math fairies that have lost their lives due to this type of canceling right here. Be really careful. I'm trying to overly stress this warning here that you cannot just cancel the X here with the X here. Because it happens so often, and it is going to cause you major problems. Yes? Yes. And let me show you why it's okay to do that, where it's not okay to cancel here. So, Caleb's a step ahead. He's factoring this. He's getting X plus 2 over X plus 2 times X plus 3. Okay? Now, I do need to do excluded values. So, actually, it's easier, though, if you factor it first before you do excluded values. So, excluded values for this. What numbers could we not have in the denominator? -2 and -3, right? So, it is easier to factor it first. On the other ones, not necessarily, because there was nothing to factor, right? So, I do have a plus sign right here. But what I'm going to cancel is I'm canceling this entire X plus 2 with this entire X plus 2 in the bottom. And what operation is happening here between the terms that I have left? Multiplication, right? So it is okay, and you can even think like there's nothing left in the top, but I'm going to have to leave a 1 there because I can't just move this to the top there. So that was 1 times X plus 2, right? So between the terms that are remaining, all I have is multiplication. So I can cancel this way here. So you can cancel things, you can cancel terms that include plus or minus signs, but you cannot cancel if there are plus or minus signs in between the things you're marking out, right? So if I had something like this, X plus 2 plus 7 over X plus 2 times X plus 3, I could not mark those out because of this plus sign right here. That would be wrong if I had that. But as long as everything is multiplied, I can cancel these terms. You guys see the difference there? So we're going to factor, we're going to cancel. We are going to get 1 over X plus 3, but we are going to say that X cannot equal -2 or -3. Yes, you do want to still include -2, even though it's no longer in the denominator. Because what we're saying is that these two things are equivalent, and they are basically equivalent. The only difference is once we cancel this X plus 2, it throws out that -2. But we want to say whatever this is equals what we started with. So for it to equal what we started with, the excluded values have to come from the original, not from the simplified version. There. So you want to do excluded values before you cancel anything. Everybody okay here? All right. Let's do a couple more here. We got like 3 more that we're going to do actually. So, let's copy down this one. All right, so we got X squared plus 2x plus 1 over x squared plus 4x plus 3 times x plus 4 over negative x minus 1. So let's factor first, and then we'll worry about excluded values because it makes it a little easier if we factor first. So if we factor first, this will be x plus 1 times x plus 1 over x plus 3 times x plus 1. And then we'll be multiplying that by x plus 4 over negative x minus 1. And whenever I multiply fractions, what do I do to multiply fractions? Like if I had 2/3 times 1/2. That's dividing. Just multiply straight across, it'd be 2 over 6, right? So really, when I have these two things multiplied, I really could act like, well, this is just one big fraction, right? Everything multiplied in the top, everything multiplied in the bottom, right? So anything in the top, even if it's in the second fraction, can cancel with anything in the bottom. But before I go any further, let's do excluded values. So excluded values are going to be x cannot equal negative 3, x cannot equal negative 1, and what do I get here, this negative x minus 1? It's negative 1 again, right? Because if you did negative x minus 1 cannot equal 0, you'd get negative x cannot equal 1, so x cannot equal negative 1, so you don't have to list it twice there. Okay, so now that I've considered excluded values, I want to cancel anything that can cancel. I see this x plus 1 and x plus 1. Those can cancel. It is okay to cancel because we got multiplication here, we got multiplication here, multiplication in between everything, right? So we've got those canceled. Do you guys see anything else that might cancel? Yeah, because this is really close to canceling with this x plus 1, right? So what I can do right here is I can factor out a negative 1 out of that. So that'll look like this. The top now is just going to be x plus 1 times x plus 4. And the bottom, x plus 3 times, and I could do negative 1 times x plus 1 here. Now, all of this is multiplied. This is not x plus 3 minus 1 times x plus 1, right? Everything's multiplied. So, in fact, a lot of times we'll write this negative 1 like out front here instead when we factor it. So everything is multiplied, so I can cancel my x plus 1s, which means that I will get x plus 4 over negative 1 times x plus 3, or you might see them distribute that negative 1, negative x minus 3. Excluded values, x cannot equal negative 3 or negative 1. So don't forget that you can sometimes take out that greatest common factor. Okay, questions? All right, here is our next one. This is fun. I find that all students love complex fractions. As if they didn't already love fractions enough. Put fractions inside of fractions and they love them. Just can't get enough of them. Alright, so, now, these look scary, but dividing fractions. It's easy as pie. Flip the second and multiply. So, this is just going to be x plus 5 over x squared minus 3x minus 4 times x minus 4 over x squared minus 2x plus 1. And then we can factor. So we'll have x minus 4, x plus 1 here. I'm going to put this x plus 5 and the x minus 4 in parentheses. It's not necessary, but it helps you keep your factors separate there. And then we'll have x minus 1, x minus 1. Now, what can be a little tricky about these is excluded values. So my excluded values x cannot equal 4. X cannot equal -1. You also have to consider x cannot equal +1. So you need to consider the denominator of both of these fractions. Then you also need to go back to the original problem. And these, do that. Go back to the highlighter here. These were both denominators here. So you need to make sure you have included those. This was x minus 4, x plus 1. You've already taken care of that. Because x minus 4 here is, it's actually this x minus 4, but because it was already included here, you don't have to worry about it. But sometimes, like, that might be x plus 6, and you need to say x cannot equal -6 also. So you got to look at the denominators of the original dividing problem, but also the denominators once you flip and multiply. So this one does not have a lot that will cancel. You just have the x minus 4 canceling with this x minus 4. And that's going to be x plus 5 over x plus 1. I think most likely you're going to see that second part written like this, x minus 1 squared, since there's two of them. But if you list them both, that's fine. If you have x plus 1 times x minus 1 times x minus 1, that's okay. There's also a chance they might multiply them back together, but I don't think they do on the answer keys for this one. Yeah. And we would say x cannot equal 4 or -1. When you have nothing else that will cancel. Yeah, nothing else will cancel. Now, sometimes it's easy to miss what cancels, so that's, you know, it sounds simple, but sometimes it's not, because sometimes you miss things that will cancel. But if you don't have anything else that'll cancel, you're done. All right, let's do one more problem, and then I'm going to get you guys started on your assignment. Give you a second to write that one down. Alright, so we got 2x to the third plus 4x squared over x squared plus 2x times x squared plus 3x over 6x plus 10. So I need to factor, but this is a different kind of factoring, one that is not difficult, but most students have forgotten about. How do I factor 2x to the third plus 4x squared? Almost. 2x squared. I'm going to pull out a greatest common factor, so 2x squared. And if I pull a 2x squared out, I will have x plus 2 left on the inside there. In the denominator of this fraction, I could pull out an x plus 2. Up here in this numerator, I could pull out an x, so I'd get x times x plus 3. What could I pull out of 6x plus 10? I could pull out a 2, and I would have x, I'm sorry, not x, but 3x plus 5 left here. Don't forget those excluded values. I mean, I say that. I forget the excluded values all the time. I've done so good on these notes, though. Usually I skip them on half of them and then get to the worksheet and realize you had to do it. So x cannot equal 0. X cannot equal negative 2. Oh, what's this going to be? 3x plus 5. Negative 5 over 3. That is just because we're doing 3x plus 5 cannot equal 0. Subtracting that 5, 3x equals negative 5. So you're going to take this last factor right here, this 3x plus 5. You're going to set it not equal to 0. You'll move the 5 over. It'll become negative, and then you'll just divide by 3. Right here, the x right here. This x. Yeah, because you're taking each piece and you're setting it not equal to 0. So that includes this x that has been pulled out. It doesn't necessarily have to be in parentheses. We even could take, I did skip one, I could take that 2. But it doesn't have a variable, right? And does 2 equal 0? No, so it doesn't really give you anything from that since it doesn't have a variable with it. So this is true, but it's not necessary to write down, right? You don't need to tell me that 2 does not equal 0 because everyone should know that 2 does not equal 0. No, it's from the numerator. Yep, so since it's in the numerator, you can have a negative 3. Yep. Only look at the denominator. Now, that's good that you said that, though, because a lot of times we forget that it's only the denominator for these. Okay? All right, so since we've got everything factored, we're going to cancel what we can. I can cancel this x plus 2 with this x plus 2. I can cancel this x with this x. I can cancel this 2 with this 2. And I think that's everything. So we'll have x squared times x plus 3 over 3x plus 5. And we'll say that x cannot equal 0, negative 2, or negative 5 thirds. You can. So if you said x to the third plus 3x squared over 3x plus 5, that would also be okay. It's not. I think that the answer key on the worksheet you're going to do is going to leave the answers more like this, where they're still factored out. But these are equivalent to each other, so that'll be fine. Okay, questions? All right, we've got a few minutes